My dear students, I welcome you all to my channel, Abrar Sir classes. Today we'll be discussing about significant figures and rounding off, which comes under the topic units and dimensions. We will first learn what is meant by rounding off. While rounding off measurements, we use the following rules by convention. Kindly note down each and every rule so that you can understand very clearly. If the digit to be dropped is less than 5, then the preceding digit is left unchanged. For example, if you are planning to drop this 2, okay, this is less than 5. 2 is what? 2 is less than 5. If the digit to be dropped is less than 5, then the preceding digit is left unchanged. Preceding digit is this one, is left unchanged, is left unchanged. So 7.82 is rounded up to what? 7.8. Similarly here, x is equal to 3.94. You have planned to drop this 4. This is less than 5. Okay, 4 is what? Less than 5. The previous number, this 9 will be as it is rounded up to what? 3.9. Now second, if the digit to be dropped is more than 5, then the preceding digit is raised by 1. For example, if you have planned to what? 7 is what? 7 is what? Greater than 5. That is more than 5. If you have planned to drop this 7, the preceding number, okay, the preceding number is what? Raised by 1. This one, okay, 6.9. 6.87, you have planned to drop this 7, which is more than 5. The previous number will raise to 1. That is 6.9. Similarly here, x is equal to 12.78. You are dropping 8. So previous number will be 12 point, will be raised by 1. Okay, the previous number will be raised by 1. Now third one, if the digit to be dropped is 5, exactly 5, followed by digits other than 0. If 5 is followed by digits other than 0, that is 1, 2, okay, up to 9 it can be, okay, it should not be 0. The digit to be dropped is 5 followed by digits other than 0, then the preceding digit is raised by 1. Now if you have planned to drop this 5, okay, and you have number 5 followed by digits other than 0, then the preceding digit is raised by 1. The preceding digit, this one, is raised by 1, that is 16.4. X is equal to 16.351 is rounded off to what? 16.4. Again 6.758, you have planned to drop what? 5. Therefore this previous number will be raised by 1, that is 6.8. 6.758 is rounded up to what? 6.8. Now next, if the digit to be dropped is 5 or 5 followed by zeros, then preceding digit is left unchanged if it is even. Okay, now here x is equal to 3.250. Okay, you have planned to what? Drop, you have planned to drop 5. Here, see here, this number is what? Even number. 2 is what? Even number. The equation is left unchanged if it is even. 2 is what? Even. Therefore x equal to what? You will be having x equal to 3.2. Okay, now I'm rounding up. Again x is equal to what? 12.650. You have planned to what? You have planned to drop 5. This is what? Even. 6 is even number. Okay, therefore this will be as it is. And this last rule is, if the digit to be dropped is 5 or 5 followed by zeros, see 5 is followed by 0 here, okay, 0, then the preceding digit is raised by 1 if it is odd. See here, you have planned to drop 5, this number is what? Odd, so it is raised by 1. Earlier this number was what? Even. This number was what? Even. This number was even. Now it is raised to what? 1, 3.8. Again 6, x is equal to 16.150 is rounded off to what? You have planned to drop 5. This is odd. Okay, this will be raised to 1, that is 6. Hope you understood these 5 rules. We'll go to the next rule, that is significant figures. Significant figures in the measured value of a physical quantity tell the number of digits in which we have confidence. Okay, larger the number of significant figures obtained in a measurement, greater is the accuracy of the measurement. Okay, if you have more number of what larger number of significant figures obtain a measurement, greater is the accuracy of the measurement. The reverse is also true. The following rules are observed in counting the number of significant figures in a given measured quantity. All non-zero digits are significant. All non-zero digits are significant. Like 42.3 has how many? 1, 2, 3. 3 significant digits. Here 2, 4, 3, 4. Okay, 4 significant figures are there. 1, 2, 3, 4, 5 significant. All non-zero digits are significant. Okay, hope you understood. Now second one. A zero becomes significant figure if it appears between two non-zero digits. Like for example, 0 is appearing here. Okay, between two non-zero digits. How many? 1, 2, 3. 3 significant figures. Here 0 is coming between 6 and 4. 1, 2, 3. 1, 2, 3, 4 significant figures. Here 0 are coming between two non-zero digits. That is 1, 2, 3, 4 significant figures. Hope you understood this. Now third one is leading zeros are the zeros placed to the left of the number are never significant, like this 0. Okay, is never significant. How many? 1, 2, 3. Okay, has 3 significant figures. This you should not count. This you should not count. And here also these two are not counted. These two are not counted because leading zeros are the zeros placed to the left of the number are never significant. Okay, 4, 5 has 2 significant figures. Okay, here how many? 3 significant, has 2 significant. Here only 1 because these zeros are not counted as 1 significant. Now number 4. Trailing zeros are the zeros placed to the right of the number are significant. For example, 4.330 has 1, 2, 3, 4. This is counted, has 4 significant. 1, 2, 3, 4, 5. 5 significant figures. 1, 2, 3, 4, 5, 6 significant figures. Okay, hope you understood this. In exponential notation, the numerical portion gives the number of significant. How many significant are there? 1, 2, 3 significant figures are there. This is not counted. 3 significant figures. Similarly, if you have 1.32, this is not. This is considered 1, 2, 3 significant figures. Hope you understood this. We will go to the next. That is significant figures in calculation. In most of the experiments, the observations of various measurements are to be combined mathematically. That is added, subtracted, multiplied or divided as to achieve the final result. Since all the observations in measurements do not have the same precision, it is natural that the final result cannot be more precise than the least precise measurement. The following 2 rules should be followed to obtain the proper number of significant figures in any calculation. This is very, very important. They may ask in the examination. One problem may be there. The result of an addition. First we will see addition or subtraction in the number of. The results of an addition or subtraction in the number having different precision should be reported to the same number of decimal places as are present in the number having the least number of decimal places. The rule is illustrated by the following example. For example, 33.3 is there. How many decimal places are there? Only 1 decimal. Has 1 decimal place. 3.11. Okay, this is the least decimal place. Here 2 decimal places are there. Now you are adding plus 0.313. Okay, 313. Now if you add up all these 3 things, it has 1 decimal place, it has 2 decimal place, it has 3 decimal place. Which is the least? Least is 1 decimal. After addition, you are getting how much? 36.723. Now answer should be reported to what? 1 decimal place. Answer should be reported to what? 1 decimal place. Therefore, after this decimal, okay, after this point, okay, we have 7 and 2. 2 should be what? 2 should be omitted. 2 is what? Less than 5. The previous number will be as it is. Okay. Therefore, answer is 36.7. Hope you have understood. Here, 2 is what? Dropped. If 2 is dropped, the previous number will be as it is. The previous number will be as it is. Okay. Hope you have understood. Next. Again, addition only. Still we are in the addition. Now how many decimal? 1, 2, 3, 4. 1, 2, 3. Okay. Now here 2 decimal places are there. Now add that. Okay. After adding, you will get this one. Answer should be reported to how many decimal places? 2 decimal places. 2 decimal places means you have to omit this 3. 3 is what? Less than 5. The previous number will be as it is 3.47. Hope you have understood. We are doing rounding off here. Okay. After rounding off, okay, to 1 decimal place, after rounding off to 2 decimal places, we are getting, okay, after rounding off, okay, because if you delete this 2, the previous number will be as it is. That is called rounding off. If you delete this 3, omit this 3, the previous number will be as it is, because 2 is also less than 5, 3 is also less than 5. Hope you understood. Now let us come to the third example. We will be subtracting. If I subtract this 62.831 minus, okay, I am going to get how much? 38.2818. 3 decimal places. Here 1, 2, 3, 4 are there. 3. Minimum is 3 decimal places. Now answer should be reported to 3 decimal places. That is after rounding off. Okay. Now if I delete this 8, 8 is what? Greater than 5. The previous number will be raised to 2. That is, after rounding off, you will get the answer 38.282. Hope you have understood this. Okay. You know that if the number is greater than 5, the previous number should be raised to 1. Next. Then answer to a multiplication or division is rounded off to the same number of significant figures as is possessed by the least precision term used in the calculation. The rule is illustrated by the following examples. Now we are multiplying 142.06 into 0.23. How much we are getting? There in case of addition subtraction, you should see least decimal places. Here you should see what? Least significant figures. Here how many significant figures are there? Only 2. Here 1, 2, 3, 4, 5 are there. After multiplication, answer should have 2 significant figures. 2 significant figures means this 6. What 6 is greater than 5? After rounding off, how much you are going to get? 33. Yes, that's the right answer. Now 51.028 into 1.31. Okay, which is the least significant? 1, 2, 3, 4, 5. Here 5. 1, 2, 3. This is the least significant number. Therefore, answer should have 3 significant figures. 3 significant figures means 6.8. 4 is omitted. 4 is what? Less than 5. Therefore, the previous number will be as it is after rounding off 66.8. Now, division. Okay, division. Now, how many significant figures are there here in the numerator? 2 significant figures. Okay, 2 significant figures. Now, here, in case of denominator, 3 significant figures. The answer, which is the least? Least is 2 significant figures. Just normally we will divide. We are getting this answer, but the answer should be 2 significant figures. That is 0.21. 1 is dropped. 1 is less than 5. The previous number will be as it is. First normally we are supposed to multiply or divide. Then we are supposed to check about the answer in how many significant figures it should have. Students, hope you have understood this. If you like this video, kindly share with your friends, ask doubts in the comment box, and subscribe for my channel, and keep watching to get different problems and different topics. Thank you one and all.